Remember, I just realized I was not recording. So, chemical equations and reactions. Followed by stoichiometry. Basically, to briefly recap, in case anyone misses in the other period, hydrogen gas exists as H2, oxygen gas exists as O2, and whenever they react, they make H2O. There's 2 oxygen on the left, 1 oxygen on the right, so we need to double it up for this to match. We have 2 oxygen, that's good. But now we have only 2 hydrogen, and now we have 4. Need to double it up. 4 hydrogen plus 2 oxygen gives us 4 hydrogen plus 2 oxygen. This 2 distributes as a coefficient. And now this equation balances. So basically 2 molecules of hydrogen gas plus 1 molecule of oxygen gas gives you 2 water molecules. That is stoichiometry, or just balancing chemical equations. But initially, we are going to focus on types of chemical equations. So, classification of a chemical reaction. There are lots of types of chemical reactions. Reactions are classified into several different categories. We have synthesis, where we synthesize a chemical. We have decomposition. That's where a chemical naturally breaks apart, or maybe when you heat it up, it just breaks apart. We have single replacement, we have double replacement, and we have combustion. By recognizing these patterns, you can classify a reaction and make predictions about its products. Everyone good? So, synthesis. Synthesis is whenever 2 or more substances combine to form a single product. This reaction is called a synthesis reaction. You are synthesizing something. When iron rust, iron metal, and oxygen gas combine to form one new substance, iron 3 oxide. And we see the balanced equation at the bottom. So 4 atoms of iron mixed with 3 molecules of oxygen to form 2 bits of rust. You'll also notice in parentheses S, G, and S. What do you think those mean? Solid and gas. We have a solid mixed with a gas, and we end up making another solid. Decomposition. Whenever a compound breaks down into 2 or more simpler substances, the reaction is called a decomposition reaction. When hydrogen peroxide spontaneously decomposes, it becomes water and oxygen gas. So we have hydrogen peroxide, and remember I told you before, UV light, if it hits it, can break it apart. And what we end up seeing is 2 hydrogen peroxide will break apart and make two molecules of water and 1 molecule of O2 gas. What do you think AQ means? And that's an L. L is obviously liquid for water. O2 is obviously gas. What do you think AQ means? Aqueous. What does aqueous mean? Dissolved in water. Whenever you put hydrogen peroxide on a womb, it depends on what it's actually doing, if it's reacting to. If it naturally breaks down, it does give off O2. When it's reacting, it can do some other things too. I don't think the reaction is... I think the reaction is hydrogen. But never mind where I was going with that. Single displacement reaction. Whenever one element takes the place of another, the reaction is called a single displacement reaction. This reaction will only occur if the more active metal will become part of the compound in the product. An iron nail soaking in copper 2 sulfate yields iron 2 sulfate and copper. So iron is more reactive than copper. So copper is happily bonded to the sulfate ion. But because iron is more reactive, it's going to come in and displace the copper and react with sulfate. Sulfate is going to more want to bond with the iron than the copper, making a precipitate of copper. Precipitate means that it comes out of solution. Double displacement reaction, whenever two ionic compounds trade their cations, is called a double displacement. One of the products will either be water, a gas, or most commonly a precipitate. Again, precipitate is insoluble in water and falls out of solution. Here you see two clear liquids mixing, and you see this yellow powder falling down. That's the precipitate. So lead 2 nitrate and potassium iodide form lead 2 iodide and potassium nitrate. Note the yellow precipitate is lead iodide. Lead 2 iodide. Basically, if you look at this, so we have the lead. The lead is attached. The lead is attached to the nitrate, and it's going to switch places with the potassium that's attached to the iodide. So lead now attaches to the iodide. Potassium now attaches to the nitrate. That's all they're doing is the cation is switching places. Note, you have to make sure the charges are balanced. This is ionic. So here we have 2 nitrates per lead. We're going to end up having to balance 2 iodines per lead, because lead is 2 plus, iodine is 1 negative. Calcium, or potassium, is 2 plus. No, it's not. It's 1 plus and 1. Everything balances. Whenever, combustion reaction. Whenever hydrocarbons is a form of carbon and hydrogen, combine rapidly with oxygen, the reaction is called a combustion reaction. Usually it happens so quickly that a lot of energy is given off all at once, and you can see visible light and heat. It's called fire. The products will be water and carbon dioxide. For example, burning methane, CH4, yields water and carbon dioxide. This reaction contributes to our greenhouse gases and global warming. Let me see if I can get alternative. Technically, a combustion reaction is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. Combustion reactions must involve O2 as one reactant. So, for example, hydrogen gas plus oxygen gas is a combustion reaction. Combustion just follows just involves oxygen. I think for the purpose of this class, though, we're only going to look at the combustion of hydrocarbons. Because technically, where is it? This reaction right here, this is a combustion reaction too. It's more accurately defined as a synthesis reaction, but rusting is actually combustion. If you could trap all the energy given off during a piece of metal rusting and make it happen very quickly, it would be a giant fireball. Rusting is very slow combustion, but it is combustion nonetheless. So, identifying chemical reactions. What is the first one? Synthesis. We have two things coming together to form one thing. It's in the form of A plus B equals C. What is B? Decomposition. We have one thing breaking apart into two things. What is C? Be very careful. You are somewhat correct, but there's a better thing to look at this. If we have a hydrocarbon with oxygen, it's always combustion. If we see carbon dioxide and water as our only reactants, our products, then this is going to be a combustion reaction. So, I'm trying to think of what I should do next. So synthesis is when two or more reactants combine to make one new element. So synthesis, synthesis. Combustion is a single element or compound combines with oxygen gas, releasing energy. That's the key. It has to be with oxygen and releases energy. If it's rapid, it's called burning. So rusting is technically synthesis and combustion. I think the notes and everything only talks about combustion whenever it's hydrocarbon. A hydrocarbon is in the form of so many carbon and so many hydrogen. So let's do a worksheet together. I didn't print it off. Let me actually just go print it. Lucas, you mind running and getting it? No, you're not supposed to be on your phone. So there's two reactions we haven't covered. That is acid-base reaction, which is simply an acid plus a base, which gives us water. That should be an arrow, not an equal sign, plus something else. And oxidation, reduction reactions, commonly just abbreviated as redox. More complicated that we'll get to later. So, classify each reaction as acid-base, redox, synthesis, decomposition, single replacement, double replacement, or combustion. There may be more than one possible answer. Let me save this. So, what is the first one? Would be double. Because two things are being replaced. So, double replacement. Again, let me just go back. This is the important thing to memorize. It's in the form AB plus CD, where A and C swap places. So we get A is with B, now A is going to be with D. C was originally with D, now C is with B. I don't like how they write this. I would personally write it like this. So because the cations doesn't matter which way, what order you do it. But I know that the A and C, the cations, are going to change places. These two change places. But it doesn't matter which order you do it in. In the PowerPoint, they did AD first and CB. But it doesn't really matter. So this and this, the lead is with chlorine. It's now with this, the nitrate. This is now with chlorine. So this is a double displacement. What is the next one? So we have two things forming one thing. So that is synthesis. It's also a redox, but we're not doing redox right now. Number 3 is what? So we have an A with a B, a C, and a D, and we're getting A with D and C with B. Another way of looking at it is the anions also replace. If the cations switch places, the anions can also switch places. It makes no difference. So the B and D are basically swapping places. So this is double displacement. And what's the next one? Synthesis. We have an A and a B, making it an AB. This is also redox. What is number 5? Double. Number 6. Decomposition. Number 7. Single. So we have an A and a B, a C, and this ends up having A and BC. So the A, or there's only one going on, so this is single displacement. What is number 8?
It's going to be decomposition and acid base. How we could start.
Where's the base?
Well, no.
Where's the acid?
Well, if it ends in water plus something.
But it needs an acid plus a base in order to get it. We haven't learned about acid and bases yet. I mean, we learned how to name them. Remember, an acid is anything that has an H, what produces an H plus ion. A base is anything that produces a hydroxide ion. So where's our base? We have O2 that does not contain OH, so it's not a base. And it doesn't contain H, so it's not an acid. It's combustion. And these last 3 have all been redox too. Redox is very fun, and that I very much hated doing the work in class, as it's very easy to make a mistake. So, number 9. This would be double. We have an A, and a B, a C, and a D. We're keeping the A and the C, but we're exchanging these 2 out. So they're like doing it by switching the anions. So this is double. What else is it? So what's our ions here for magnesium and this magnesium hydroxide? We have a magnesium plus 2 plus and an OH. So what is this? Anything that produces OH ions is a base. What's the two ions for this? H2SO4. What's their two ions? No, this isn't good, guys. This entire unit requires your knowledge on the previous two units. So H plus and SO4 2 minus. What is this called? What is H2SO4? What's the name of this? What is SO4? It's a sulfate. AT, because S is an exception. S is the 8th version is O4. And this is with hydrogen. So this is going to be known as the 8 becomes an Ike, or ick. Sulfuric. Sulfuric acid. The 8 name for the acid becomes an ick. So this is clearly an acid. So we have a base plus an acid, and we're making water. So this is also a acid-base reaction. What would 10 be? Yes. Be very careful. By the end of this unit and the next unit, and the unit after it, you're going to realize that this is a super, super, super common base. NaOH is going to be used everywhere as our common base. H2SO4, sulfuric acid, is going to be our most common acid we'll use. However, this is not an acid-base reaction because this does not produce hydrogen ions. So this is non-acid.
Excuse me, teachers, for a quick announcement, just a reminder, the burgers will be ready. If you have junior high lunch, that's when you go to get your burger, is during junior high lunch. And they're down in the gym foyer. Same for high school. If you are a high school teacher during high school lunch, is when you will go get yours. Thank you.
So what is this one? It's combustion. It's also a redox. Actually, I'll give you a hint. All of these are redox after it. We study redox reactions very, very much. And to the point where a lot of time all we look at is redox reactions. Actually, redox is going to be the question you ask. Will these two things, when you mix them together, react? Well, is it a redox reaction? If it is, most likely it will react. That's the reason why you see almost every one of these is also redox. Unless some other mechanism is going on in place. So, iron plus oxygen. What is this? Synthesis is the number one thing. Yes, technically you can call it combustion, but let's go with synthesis and not get confused. And this PowerPoint and this unit only says combustion is with a hydrocarbon. And hydrocarbon is in this format. Number 13. Mm-hmm. All right. 14. Decomposition. And the last one. Yeah, it'd be single. Alright, let's try. These were all incomplete equations, or not balanced. These are unbalanced equations. We'll learn about stoichiometry later, and how to actually balance them. Question. Right, or I should say, write the equation for the decomposition of calcium carbonate. So you should know decomposition has an AB that ends up making A plus B. Mm-mm. So I will give you another hint on this. So this is I'm choosing this problem as an example of this can be more complicated than just AB goes to A plus B. So what is the formula for calcium carbonate? So we have a Ca plus and we have a CO3 negative. Now, calcium is a metal. Calcium can form metallic bonds with itself, meaning we can end up having calcium as a solid, not an ion. Calcium can form into elemental calcium. That is fine. Can CO3 exist by itself? It's an ion. Can it become not an ion? No. It's just like you never see sulfate existing in the world. You see it bonded to something. This can't exist by itself. What is this very close to? Was the closest carbon dioxide. So this can turn into carbon dioxide, and we're going to have a missing oxygen. Now, even though we can make pure calcium, we're going to have a smile on this should be 2 plus. And that should be 2 negative, right? So, but we have a problem. Can oxygen exist by itself? Yeah, it doesn't have to be. It can be O2 gas. That is fine. So this and this is fine. So we could say, and this is wrong, we could argue that this is the equation. You'd be wrong. The reason why this is wrong is whenever the calcium gets by itself, it's missing 2 electrons. Oxygen has 2 additional electrons. Now, what this could do is just happily... So, calcium 2 plus and O2 negative. This is missing 2 electrons. This has 2. Now, calcium can come over here and ask the bar just grab those 2. They can donate it and do whatever. Then 2 oxygens will come and group together and make an O2. Calcium is taking its 2 electrons from the oxygen. It's now happy. What's going to more than likely happen? Calcium oxide. This is an ionic compound. So the real equation is CaO plus CO2. And this is a solid, and this is a gas. That is the equation. It is much more likely that calcium will just simply bond to the oxygen than take its electrons and run. Right? So, another way of looking at it is when we break this apart into its ions, you got 2 plus and a CO3 2 negative. This is going to want to decompose again. So there's a multi-step. This is going to want to decompose into CO2 and O2 negative. And then we have left this, and this. These 2 would want to combine together to make CO. Remember, when we make molecules, compounds, they have no charges. We need to get rid of the charges.